In the previous chapter, we talked about arrays. Now we will get familiar with the stack and queue data structures. A stack is a simple linear data structure used for storing data. The last element inserted is the first one to be deleted. Hence, it is also called the last in, first out LIFO or first in, last out FILO data structure. A stack is an ordered list in which insertion and deletion are done at one end called top. Pile of books is a good example of the stack. You put one book on the table, then put the second book, and so on till you have a stack of books. When you take a book from this pile, you take the topmost book. Notice that this was the last book you put on there. The next book you take will be the second last book, and so on. This is how a stack works in programming. Different objects are held in memory in this form, where the first object to enter into memory is the last one to be extracted out. Now let's discuss some of the primitive operations that can be performed on the stack. We can add items to a stack using the push operation. First, we initialize a stack. We have to specify the size of the stack when we initialize it as shown in the figure. If we push an integer value 10, the top pointer points to the first element of the stack. If we push 20, then top pointer gets incremented. Similarly, if we push 30 and 40, the stack structure looks like this. This stack can hold one more integer, so if we push 50, the stack becomes full. If we try to push another integer into the stack, then we get a stack overflow error. Stack overflow error occurs when we can't add another element in the stack. Another operation which is used to remove items from the top of the stack is a pop operation. Here, we can remove the top element 6 by using the pop method. Similarly, we can remove 8, 3, and so on. Is full operation is used to check if the stack is full, and to check if the stack is empty, we use isEmpty operation. Top or peak indicates what value is at the top without removing it. Here, the top operation would return value 6. Now we are going to look into another linear data structure, queue. A queue is a FIFO data structure, first in, first out. It is used to implement a first come, first served approach. Just imagine people waiting in an ATM queue. The first person to get in the queue will be the first person that is served. Anyone that is added at the end of a queue will be the last one to be accessed or dequeued. Pretty simple, right? So far, we have understood what a queue is. Now we are going to talk about the common operations of the queue. We can add items at the end of the queue using enqueue operation. Let's insert some element into the queue. Before adding any item to the queue, we have to initialize it. As we can see it in the figure, we have initialized the queue size to 8. When we enqueue the first element in the queue, front and rear of the queue point at the first index of the array. While adding an element into the queue, the rear keeps on moving ahead and always points to the position where the next element will be inserted. And as shown in the figure, the front remains at the first index. Let's see how we can remove elements from the queue. Item is always removed from the front of the queue using the dequeue operation as shown in the figure, and the front always points to the element next to it. Similarly, we can add and remove elements from the same queue. The element will be removed from the front and added from the rear. And similar to the stack operations, isFull operation is used to check if the queue is full, and to check if the queue is empty, we use isEmpty. In this chapter, we looked at stacks and queues, which are both linear data structures. Then we discussed on some commonly used stack and queue operations. These data structures are pretty similar to each other. The main difference was on how the elements are removed from each of them. In a stack, the last element inserted is the first one to be deleted. So stack is last in, first out, or first in, last out data structure. Whereas in a queue, it is used to implement a first come, first served approach, so it is a FIFO data structure.